This is the project that I want to show you today. Not modeling the car itself, plenty of tutorials out there for how to do that. I want to show how to animate the lights for easy keyframing and easy animation. In this model, I have lights set up tied to custom properties, which are Boolean values, which can turn the lights of the vehicle on and off just by changing these simple properties. We can turn on the parking lights like this. Just click that one property and notice that we've got lights on all over the car. And you'll notice, of course, these are different lights in different locations, so these use different lighting devices, different materials, different emission shaders, different lamp objects, and yet they all responded to that one single property. Furthermore, this model can animate activating the brakes and even animating the turn signals with just a simple 0 or 1 command. This way, you can simply keyframe these individual properties to make the vehicle's lights operate the way that you want them to, without having to worry about keyframing all the little nitty-gritty things with all the different lamps all throughout the vehicle. It even takes into account certain advanced scenarios, such as what happens if the vehicle needs to be braking and one of the turn signals needs to be on as well. Just like what the real vehicle would do, the brake lights are ignored on the side where the turn signal needs to be flashing, and the turn signal flashing takes precedent. And here with the brakes, parking lights, and a turn signal on all at the same time. And the way that this is set up, that same turn signal property also governs both the front and the rear turn signals so that both of these lights activate as they are supposed to. Fog lights on, and everything back off. I figured when I was trying to do one of my first models, my first animation, doing a vehicle, that there must be a simpler way to model the lights in terms of activating and deactivating the lights at various times. And I did my research and I couldn't find anything out there as to how to do that, other than just keyframing the emissions of each individual shader on each individual light, each one using a different shader, of course, changing a lot of properties and a lot of materials, all of which have to coordinate perfectly. You want the front and rear turn signals to flash at the same time. You know, it can be done, but that's a lot to coordinate with various keyframes. So I did some additional research and did some thinking, and I came up with this solution on my own. One that I have not seen published anywhere online, so I thought, what the heck, why don't I try doing a Blender tutorial? So, in just a moment, I'm going to show you how to set up everything so that you can make a vehicle's lights work just like this. Okay, so here's the model that I'm going to set up. First thing, I need to show how some of the lights are set up on this model, because that makes a difference in how the drivers are going to be configured. There are a bunch of different ways that you can model lights on a model in Blender. This is a simple way, probably not the best, but it works well for me. In this case, the mesh is simply the shape of the outer lens of the appropriate light. The texture is simply an image texture that I captured from the lights on my actual car. And the way that these shaders are configured, if we go over into the shading tab, we have the image texture of the light fixture, and it is sent into a principal BSDF. This does the light when the light is not illuminated, and the same texture is passed into an emission with a strength of about 10, and then you have both of those passed into a mix shader and out to the material output. And you can see the effect of this then. The factor, 0, represents when the light is off, and 1 represents the light when it is on. Not all of the lights are set up this way, and this will actually give us an opportunity to look at a few different options for how lighting can be modeled and how that affects how we're going to animate these lights. Lights in the front, for example, the front turn signals actually use a clear lens and a light emitter, a Blender lamp object behind it. One in front for the main bulb and one on the side for the parking light bulb. To automate the lights turning on and off, I'm simply going to be changing some properties in the shader, or in the front in the actual light emitters. As a result, every light that needs to be able to be activated independently has to have a separate material. So in the case of the halos, this is a modified halo light, where the outer ring of the halo is the parking light, the inner section of the halo is the brake light or the turn signal. And on this car, the inner and outer pair on either side are identical. They're actually wired directly to each other inside the real car. So these two lights behave identically and these two behave identically, but left and right, because their turn signals, do not behave identically. So even though the texture looks exactly the same, there has to be a different texture object so that one of them can be set on and the other one can be off. The same is true of any other light on the car. In the case of some situations, like these side markers, for example, these are not turn signals. All they are parking lights, so they can actually be exactly the same texture. They'll all be on or off at the same time. Alright, so let's see how we're going to set this up. So first we need a place for the custom properties, and I think the best place for it is on the body of the vehicle right there. So I'm going to click on the Object Properties, and I'm going to go down to Custom Properties, and I'm going to create some custom properties for this vehicle. Now you need to create a custom property for every lighting system that we need to have on the car. And in this case, they need to actually be booleans. There is no boolean in this list, but it's pretty easy to create just using an integer, and as a matter of fact, it defaults to the min being 0, the max being 1, and the step being 1. So this value will only be allowed to be 0 or 1, on or off. I'm going to name this one parking lights. And then go through and create your properties for every other lighting system that you need to animate on the vehicle. In this case, I have the reverse lights on this car, but I haven't actually fully modeled them yet, so I'm not going to be messing with those. And in front, this car has flip-up headlights, and I have not modeled the headlights. So I'm not going to be doing the headlights on this one either, but the channels that you create are going to depend on the vehicle model that you're trying to set up. Once you have custom properties for all the lighting systems on the car, there's one more that we're going to need. It also needs to simply be an on or off, so it can be created the same way. I'm going to call it Flasher. This property is how we are going to make the turn signals work. So the next step is we are going to go in and do some keyframing. So when you click on the vehicle, you will have this Properties tab that you can expand under the item, and you have all of these properties listed here. So the one that we're interested in right now is going to be the Flasher. Let's go ahead and bring up the graph window, and we're going to animate the flasher. So I'm going to the first frame in the sequence, and I'm going to set the flasher is already 1, insert a keyframe. Then I'm going to move forward 330 milliseconds. The period of the turn signal flashers on the C5 is about 660 milliseconds. Yes, I did actually have to time that one time. So we're going to go ahead 330 milliseconds, that is half the signal. And this is something where, if someone knows a better way to do this, please let me know, because the timeline deals only in frames. Therefore, getting the timing of the signal correct is going to depend on the frame rate of the animation that you're trying to do. In this case, I'm setting it up for 24 frames per second, so I'm going to do 24 times 0.330. And that tells me that that is going to be frame 8, where we want to see the flasher go to 0. So I'm going to set the flasher to 0, insert a keyframe, and actually I'm going to turn on auto keyframing here so that we can save some time. And we can see this signal here. We need to go ahead another 8 frames, so that one is simple. Go to 16, and that is where it needs to turn back on again, set that keyframe, and that is our flasher pattern. So press T and select constant. This way the keyframe will remain in its previous state until a new keyframe is encountered, and that is going to give us our instant on and off signal. This is going to be the signal for the turn signals. Now we need this to go forever, so we're going to go in and add a modifier and add a cycles modifier, and there we have a forever 330 millisecond on, 330 millisecond off flasher signal, and we're going to use this in our drivers for some of the other lights. Now I'm going to go ahead and default all of these back to 0 so that we can get started actually making them work. So let's start somewhere simple. One of the simple ones is going to be the high mount brake light, because it is simply on when the brake lights are on and off when the brake lights are off. So we're going to go into this one, and we're going to go into its material. Again, it has a unique material. There's no other light on the car that behaves exactly like this one does, and its factor is going to be what turns it on and off. 0 for off, 1 for on. Right click, add driver. Now for this driver, we're going to select a single property. We need to select the vehicle, which is where our user properties are. And I should have picked a shorter name for this. And it is going to be this guy right here, which is my actual vehicle body. This panel likes to close itself very frequently, and then we need to paste in the path to the driver. You can type these in, but it has specific syntax, so it is actually safer to go to that property and right-click copy data path. That way you can't make a mistake. Going back to the return signal, bring this edit driver back up, and I'm going to paste that there. So that's what the syntax looks like, but if you get it wrong anywhere, your driver's not going to work. If it is an error, this path will highlight itself in red, so you'll know right away that you did something wrong. Either your object is not the correct object that had the property, or you typed the property in incorrectly. And even though there's only going to be a single variable in this case, I'm going to name this something more logical, because very soon we're actually going to encounter drivers which needs to take into account more than one of these variables. So I'm going to call this one brakes on. Alright, so now we need to enter a Python expression that represents what the value of this should be. And this is going to be using a simple trinary conditional operator. So what we want this to do is we want this is the factor now, we want it to be 1 if brakes on, else 0. Now, brakes on, of course, is our user property. It's our effective Boolean. It is actually an integer, 0 to 1. In Python, as well as almost every other programming language, 0 is going to be false, and anything other than 0 is going to be a true. So this is going to evaluate, so to put a 1 in our factor, I really wish that would stop going away. If someone knows how to keep that up, please let me know. A 1 goes into our factor if brakes on is 1, else we get 0, that is where it is off. And we can go and we can test this right away. We can turn brakes on, and the brake light turns on. Brakes off, brake light turns off. Now let's go ahead and let's do some of the other easier ones first, and then we'll look into some of the more complicated stuff. So one of the next easy ones on the back here is going to be this outer halo. This is just the parking lights. So in similar fashion, it is going to be a very simple setup. We simply need to have a 1 or a 0. And I'm going to go in here, and the only thing it depends on is parking lights. So before I even bring that up, I'm going to do copy data path so that I get that proper signal name in there so I cannot make any mistakes. Then I'm going to go back into any of the turn signals, any one that has this outer, so all 4 of them have this same material, and I'm going to right click on that factor and I'm going to add a driver. Once again, our driver is going to be a single property. Our property is going to be on C5 coupe rigged. That is the body of the vehicle. And our path, paste, parking lights, and I'm going to name this variable park lights on. And this is going to end up being exactly the same type of expression. So this is going to be 1 if park lights on, else 0. Now, there are simpler ways that I could write this expression, but there is a reason why I'm doing it this way. You could actually just put park lights on into this as is, because it's either a 1 or a 0, and we want a 1 or a 0, and we want those to be matching perfectly. But some of the others are not going to be just 1 and 0, and that's why I'm doing this expression to keep it similar. So we're going to go ahead and turn the parking lights on now, and all 4 of the lights turn on because they are all using the same material. But here is where things start to get cool. So we have the side marker that actually uses exactly the same signal. It goes from 0 to 1 on its factor. When the parking lights are on, it behaves that way with no other factors. We have that already on this outer, so I'm going to right click on this purple factor here, and I'm going to say copy driver. Then I'm going to go over to the side marker light, which is set up the same way, the principled and the emission, with the factor being what controls whether it's on or off. And I'm going to right click on this and I'm going to paste driver. And now, if we select our body and toggle the parking lights on and off, we now have all of these lights respond to the parking lights custom property. Alright, Now before we go to the parking lights on the front of the car, I'm going to go ahead and finish off the lighting on the rear. Again, I'm not doing the backup lights, but let's do these. Let's do the inner parts. Now this is where things are going to get a little bit more complicated. First, you need to consider what the behavior of the lights are on the actual car. So what do these lights do? Well, the inner section turns on full brightness whenever the brake lights are on. But if the turn signal is on, it blinks with the turn signal. Now, even if the turn signal and the brakes are on at the same time, the turn signal takes precedence and the brakes do not show. So if we had, say, the right turn signal on and the brake lights on, we should see the center mount light lit up, we should see the left-hand side lights lit up constantly, and the two right side lights will be blinking. So we have to create a driver expression that is going to take care of all of that stuff, and we're going to be able to do that in a similar way to what we just did with all of the other lights we've done so far. So let's get to it. This one's going to be a little bit more complex, but it will not be too bad. So select one of the rear tail lights and select the material that governs the inner section. In this case, it is my halo LED right, and remember, because we have to be able to differentiate the left and the right side being on, these materials must be different. They have to have two separate factors so that they can work independent of one another. But let's go ahead and right-click on Factor, and let's add a driver. Now the first thing to start off with is what parameters are we going to need to take into account to make this driver work. Going to be a single property. So the first obvious one is the brakes. So let's right-click and copy data path on the brakes and go back in and bring up our driver window and paste that here. I'm going to use the same naming convention that I did before. So this variable is going to be called brakes on. But in this case, we need to take into account other variables. So we need to go back to the body, and in this case, signal right also factors in to this lighting system. So let's copy the data path for right, and then go back into this driver, and add a second variable. This is also going to be a single property. It is on the same vehicle. And paste the data path for signal right. And I'm going to call this signal on. I'm not going to say signal right on because we're going to copy this driver over to the left side. And if we do it right, all we have to do is change the path variable and it will still work in the same way. So that is why I'm only going to call it signal on. There is one more thing that this has to depend on, and I mentioned this before earlier. And that is where this flasher signal comes in. This is how we affect blinking turn signals. So let's copy the data path on the flasher user property, go back into the driver, and let's add a third variable. And this one's going to be, I'm going to call it flasher on. So this also helps to clarify that you're getting a 1 when that flasher light is actually on. And paste our data path. Now, we need to create an expression that is going to handle all of these different cases. So how are we going to do that? Well, it's actually not too hard. We're just going to have to combine a couple of these conditionals together. So we're going to start with the simple case. We want this to be 1 if brake on, else 0. And we're going to enclose this in parentheses so that it can be its own initial condition. So we're going to have it behave like the brakes, basically behave like the brakes, if not signal on, else. And what do we do if the signal is on? Else we do 1 if flasher on, else 0. So by placing this in parentheses, this entire second conditional becomes the else clause of this conditional. Likewise, this is the true clause of this conditional. So going through this again, it's really not very complicated. So what we want to do is, we want 1 if the brake is on, else 0. That is standard brake behavior, on with the brakes. If not, signal on. So if the signal is off, it behaves like a normal brake light. If the signal happens to be on, it goes into the else, in which case 1 if flasher on, else 0. So if the signal is on, it ignores whatever the brake signal tells you to do, and it will simply turn on and off with the flasher. So let's see if it works. Now, we are able to see any of the static lights just by toggling the parameters here. So for example, we can see our brakes turning on and off. To actually see the turn signal, you do need the time to be moving those. So you have to click play and let your simulation actually run. So let's try that. So our flasher, you can see going back and forth between 1 and 0. So let's turn on the right turn signal. Turn that on, and there is our right turn signal blinking. And now what happens if we push the brakes? The brake light comes on, this turn signal continues to blink with the turn signals. Now, when you actually render this out, it's going to be blinking a little bit faster than that. I'm not able to get all the way up to 24 frames per second, but you can see that it is working. How cool is that? All right, now let's do the other side, and it actually is very easy. So we're just going to right-click on that driver for the inner section, go over to the opposite side. So I have the halo LED left, right-click, paste driver, and then open it up and edit the driver. And I do like to copy and paste these, but in this case, it's really simple. All we need to do is change this to left, because I know that that's what I named it. And again, this is why I called it signal on, so that I don't need to change any of this. I just need to change what signal on means on the left. And now what happens? Immediately we see we have our brake lights on, so all 4 of the tail lights have their brake lights activated, and so does the high mount. So let's go back in here to the body, where our custom properties are, and let's turn on the left turn signal. And again, we'll have to play. I'm going to turn the right one off, and there we go. The vehicle's brakes are on, and the turn signal is flashing. And it should be very obvious, I did not give a separate property for the 4-way flashers, but if you need to animate that, just turn on both the left and the right at the same time. They are timed together because they're both dependent on the same flasher signal, so that will always work and do exactly what you expect it to do. Turning the signals off, and we're back to our brake lights. We can flip our parking lights on, and there we have our parking lights. So this is great progress so far. This is all automated now. When you are actually doing your animation and you're busy making your vehicle move and handling everything else that's happening in the scene, all you got to do is keyframe these guys, and all of this stuff happens automatically and you don't have to worry about it. All right. So let's pause that. Let's turn our lights back off again, and let's move on to the next thing. So up in the front of the vehicle then, we have a couple of lighting systems that we have to model here. The first one that I'm going to do, because it is actually very simple, is let's go ahead and do the fog lights. So in this case I have the white fog light, and this one is using the same mechanism as the rear lights. The difference is, instead of using a texture node, it actually uses a bright emission shader, or basically what looks like a glass for when the light is off. So we're going to do that and make this one work the same way. And once again, it is just the factor, and it is from 0 to 1. That's going to change in just a minute when we do these outer lights here, but that will be easy enough to do. So let's go back to our body, and I'm going to right click and copy the data path on fog lights, so I don't have to go back and forth between the two of them. Now these guys both use the same material, because the left and right fog light cannot be turned on independent of one another, so doing this with one side will take care of everything. So we're just going to go ahead and add a driver, single property, same vehicle model that has that, paste this, and we're going to call this fog lights on. Why not? And this is as simple as the other ones. So this is going to be a factor, should be 1 if fog lights on, else 0. Oops, not O, but 0. Simple as that. Click on our body where our properties are. Let's turn the fog lights on. There they are, on and off. All the lights in one place. Now, let's get to the last one that gets a little bit more complicated, and that is just because I modeled this a little bit differently so that we had a chance to show some different things. So this one, instead of using a texture that we're going to change a factor on, this has a translucent lens, and it actually has emitters inside of it. So we're going to be modifying the power of these two emitters in order to turn these lights on and off. So why don't we start with just the parking lights. So the parking light emitter, power, right click, add driver. And of course, if I had remembered to think ahead, I would go in here and I would copy the data path for the parking lights first. So let's go back into this, edit our new driver, and just like before, single property, the vehicle body, paste the data path. I'm going to call this one park lights on. And so now, instead of just going from a factor of 0 to 1, I found that roughly 25 watts seemed to be about right. So we're going to do 25 if park lights on, else 0. That is going to change the power output of that emitter whenever the park lights are on. So let's try it out and see if it's going to work. And there we go. That is probably a bit too bright, but let's not worry about that for right now. We can fix that later. Let's go ahead and implement the same thing over here. So we're going to go back to the driver side. I'm going to copy the driver. And on the passenger side, I'm just going to paste that driver. And because these don't need to be differentiated to left and right, that's all there is to it. Now when you turn your parking lights on, you get the front side markers activated, and of course this same driver drives all the other parking lights throughout the rest of the car. So you turn on this one user parameter and you have all of the vehicle's parking lights turned on. Of course we haven't finished the implementation yet, so let's go ahead and do that. So the next one ends up getting just a tad more complicated once again. I should still have it in my clipboard, but let's go ahead and copy the data path here. Oops. And let's go to the main emitter and add a driver. Now, let's review what the main emitter does on the front turn signals of this car. So in this case, I have not modeled the DRLs that this car originally came with because I don't like them, so I disabled them on my car. So I have not modeled the DRLs. We're not going to worry about that at all. So the behavior we're looking for is for this light to blink with the turn signals in bright mode, bright off, bright off. It should light up dim with the parking lights. And just to make things extra complicated, if you want to go that extra degree to make it look super realistic, if the parking lights are on and the turn signal is on, this should actually blink bright dim, bright dim. If the parking lights are off, it should blink bright off, bright off. So we can do all of that with a similar expression, and it's really not that complicated. So let's go ahead and do that. So let's go into our driver, and we need a few variables here. Single property, same body, parking lights. I'm going to call this park lights on. Add another variable, go back to the body, and this is the left side of the car now, so we're going to copy the data path for the left, go back to the left main emitter, edit driver, and our new driver then, also on, also on the same body, paste, so this is our signal left. So just like before, we're going to call this signal on, and it is driven by the same user property that's used for the drivers on the rear lights. So this is going to flash along with the rear lights this way. And just like in the rear, in order to actually write the function for this, we also need this flasher input. So let's copy the data path for the flasher, go back to the main emitter, edit the driver, add another input variable, single value. That is our body, paste that, and just like before, we're going to call this flasher on. All right, so how are we going to get this thing to do what we want it to do? Let's start with just the parking lights functionality. So we're probably going to want to change how bright those are, because I think that's too bright there, but let's just leave it the way that it was for consistency. So let's start. So we're going to do 25 if park lights on, else 0. So that's going to be our parking lights functionality. Now, let's go ahead and wrap that in parentheses. We want this to behave as a parking light if not signal on, else. Now, what do we want it to do? Let's make our into parentheses here. What do we want it to do if the signal is on? Well, we can go ahead and get a little bit more complicated here and try to handle every possible case. So this is the situation if the lights are on. So what do we want it to do? We want it to do, say, 50 if flasher on, else. And what is else? So else in this case, else is going to be 0 if not park lights on, else 25. Does that expression make sense? All right, so we're going to go to an output of 25 watts if the park lights are on, else we're going to go to 0. That is the case if the signal is not on. If the signal is on, then we go to the else of that signal, and the else of that signal is we want 0. If the signal is on, then we want 50 watts output if flasher on, else. So that makes the light emit bright whenever the flasher is on. Otherwise, when the flasher is off, we go to 0 if the parking lights are not on, or 25 if they are. So this gives us our bright dim, or bright off signal, depending on what the state of the parking lights is. So let's give this a try. So this is representing parking lights, and yep, I definitely need to make some major adjustments, but hey, having it extra bright makes it easier to do my illustrations here. So here are our parking lights. We'll turn the parking lights off, and those lights go out. Actually, let's go over here a little bit. There's a camera in the way. So you can see parking lights back on, rear markers turn on, front markers turn on. Parking lights off, let's turn on the left turn signal. And of course, once again, run your simulation because the blinking effects do not work when the simulation is not running. So there's our blinking front turn signal, blinking rear turn signal just by changing that one property. We have our front and rear turn signal blinking, and if we turn the parking lights on again, then we get that side light on, and we have a bug in our expression. So let's go figure out where I did this wrong. Oh, nope, never mind, I didn't. The problem is you can barely see the difference between the two. So let's let's go make some adjustments here so we can try to see something that looks a little bit better. What if we go into edit driver? That's the park emitter. Let's do it on the main emitter first. Edit driver. Let's try, I don't know, let's go way down. Let's try something like 5. You can sort of see that. Home. If you weren't afraid of having a long list of input variables and some other complication, those would actually be good candidates to become other user properties on your body in case you think that you might need to adjust what your bright and dim settings are going to be. But let's go ahead and change this also. I think actually at least these side markers I want to say on the real car before they're converted to LEDs are about 7, but I'm going to go to 5. Alright. So it's not quite as dramatic as you would think, but you can certainly see it. We have our turn signal blinking, and when the turn signal is off, it goes back to being the parking light. This was actually a very quick job on modeling these lights, which is why it's actually not very good. So certainly put a little bit more time into modeling your lights, and this will end up looking a whole lot better. But let's go ahead and make the other side work. And that is pretty darn simple now, isn't it? So let's right click, copy driver, go over to the right main emitter, and paste that driver. And you notice it's not doing what it's supposed to right now because we need to go in here, we need to edit driver, and we need to change the data path of the signal on to right. And there you have it. We have our right turn signal off, left turn signal on. Let's go back to the body. We can turn off the left turn signal, turn on the right turn signal, and we have our right turn signal going. Parking lights are on, so we have the side markers. We have our right turn signal going. Let's hit the brakes. Turn the brakes off. Turn the signal off. Turn the parking lights off. So there you go. And now we have a great and easy way to automate all of the lights on this car so that you don't have to worry about keyframing each individual factor, each individual emitter, each individual material, and make sure that they all sync up correctly. So let's go ahead and do a simple scenario here with this sample car. Let's say we'll start at 1, and I'm going to go ahead and save as so we can not disturb this model and go to a different one. So let's see how this can work in practice. So let's go back to the beginning and let's just do a scenario. I'm not going to model moving the car or driving it along a path or anything like that. That's a topic for a whole different discussion. Let's just consider some lights. Let's just say we start at 1 and the vehicle drives for, say, 2 seconds, and then the driver puts on the right turn signal. We'll go ahead and add a keyframe. So now we're going to 1. And we need to, don't forget if you want everything to start off on even footing. Let's go ahead and keyframe all of our lighting controls to 0 to start with. Remember, don't mess with Flasher. It just does its own thing by its own setup keyframes, and you don't need to do anything else with it. So let's go 2 seconds ahead, and we're going to turn on the right turn signal. 1 second later, the driver is going to apply the brakes. Let's say 2 seconds later, the driver is past the apex of the turn. They're going to turn the brake lights off. 1 second later, their turn signal is going to self-cancel. 2 seconds after that, the car is going to enter a tunnel, and the driver is going to turn on the parking lights and the fog lights. And let's say another couple seconds after that, the driver's going to turn on the left turn signal to change lanes in that tunnel to overtake a slower car. And after a couple of seconds, we'll turn that signal off. 2 more seconds and we'll exit the tunnel, and the driver will turn the parking lights and the fog lights off. Okay, now let's see. Let's actually say here, signal left. So this is where I said my driver wants to turn the turn signal on. Let's also say that right about here, the driver has to hit the brakes in order to slow down just a little bit. And then he turns the brakes off, then momentarily later hits the signal, changes lanes. Okay, so there's a simple scenario. So let's see what this looks like, because there's one last thing we need to make sure that we do here. Going into the graph editor, and we'll see what all of our different signals look like. Let's see, we're going to want to hide the flasher because it's going to make everything confusing. So this is what all of our signals are going to look like right now. And just like we did with the other one, I've actually never tried this, so maybe someone could help me out with it. If you keyframe these like this, I think they're only going to go, yeah, that's what the graph editor is showing. So since this is programmed to only accept a 1 or a 0, it's not going to interpolate a smooth curve in between the two because it won't accept those values. But notice that the actual signal is changing halfway in between the two data points and not where we actually want them to be. So I don't know if you can do this to all of them at once or not, but highlight your signals, press T, and switch to constant interpolation, and it actually looks like you can do those all at the same time. So that way, when these keyframes actually get hit, that is the moment that we see that is the moment that we actually see the effect. And let's go out here and we'll go ahead and make that the end of our simulation. So I'm going to go ahead and set up a camera, and we're going to render this simulation, and then I will show you how it looks in the end. And as far as the lights are concerned, when it came to the animation, the only thing that I did was just change these values. And with auto keyframing on, that became even simpler. Once they were set up to what do they call it? Constant interpolation. All you got to do is move the timeline cursor to where you want it to be, change the value, the keyframe is set automatically, go to the next point where you want to change the status of that light, change it back to the way that it was before. Simple as that. So let's see what the end effect ends up looking like.